All right, we are going to start this lesson with a little bit of craziness. We've got a picture here with no numbers whatsoever, but it tells us that the volume and the surface area are equal. So the volume of a cylinder is pi r squared times the height, and the surface area of a cylinder is 2 pi r times the height plus 2 pi r squared. And they are asking us to find what the height is. Now, a lot of students look at this problem, and I want to start with this because I want you to see, there's no numbers here besides these 2's, right? There's no numbers here. So they're not asking you to find a number. They don't want h equals 10. What they're asking you to do on a problem like this is to take these formulas, and take a variable, like in this case, we're looking at the variable h, and get it all by itself, so you get h equals, and then whatever else it equals. And it's going to be a bunch of pi's and r's squareds. And it's going to be this big hulking mass of letters. And the reason we would want to do this is because there are situations where maybe we know certain things, right? We know certain, in this case, formulas, and we need to rework them to focus on a different dynamic, a different aspect. I don't know if you guys ever do this in different scenarios. Well, I should say I don't know. I know you do this in different scenarios. I can just give you an example for me. Okay, there are times where maybe I have a certain outcome I want, and I need to figure out, how do I get that outcome? I'm thinking a lot, you guys, if I've talked about it, I know I do some woodwork, and I'm not great at it, but there's times where it's okay, I've got to figure out, how do I get this end product? Well, here's the tools I have. I know that they can do these things. Can I figure out a way for them to end up doing this? And that's kind of what they're asking. So this is what we're going to do today, is working with formulas like this in order to solve certain things. That's kind of the idea. How can we use a formula for one to write a formula for a different measurement? Okay. So for example here, let's start with something maybe a little simpler than the one we were just looking at. It says write the formula for the area of a rectangle. Now there are numbers up here, but they don't want us to deal with numbers. They say write a formula. Well, area equals base times height for a rectangle. And then it says solve the formula for b. And this is the idea. I could plug in the numbers, and if they said solve for b, I could do it that way. I could figure out what b is. But sometimes, maybe I gave you a bunch of problems and I asked you for b. You wouldn't want to work through the math on all of them if you could redo the formula. So in order to solve for b, what we're going to do, it's very simple. We're just going to try to isolate this letter. Well, think about this. If there was a number here, this is b times something. And in order to separate two things that are multiplied together, you divide them. I know it's weird, right? But h divided by h cancels out to be 1. And in math, if I do something to one side of an equation, I also have to do it to the other side. And so I started off with a equals b times h, and what I'm left with is that b, all by itself now, is equal to a divided by h. And again, maybe, just maybe, manipulating and reworking this formula will allow you and help you to solve things. Notice on this one, it says use the new formula to find the base. Well, notice how nice this is. If I use this formula, the base equals the area, which they gave me, divided by the height. And if I divide those out, I'm going to get a total of 16. In this case, meters. Okay, and you can do that with things like volume and surface area. Okay, we're not going to do this for sake of time. I want you guys to see, what if they asked us to do something like this? Solve this equation for y. And all we're trying to do is take all of the math we've been doing, solving equations, and we're dealing with situations where there's variables now. So we want to get this y all by itself. So the first thing I'm going to do is treat this just like a number. This 5x, we're going to treat just like a number. And so if I wanted to move it to the other side, I would subtract 5x. So I now have 2y. I want to make sure I keep my equal sign, right? Equals my 5x's canceled out. 5x minus 5x. And so I end up with, I'm going to write it this way because we typically put our variables first. Negative 5x plus 6. This is a positive 6. So negative 5x, it's negative, plus 6. Now is my y, right now, is my y all by itself? No, right? There's a 2 there. So now I have to divide both sides by 2. And we end up with y equals negative 5x plus 6 divided by 2. For this problem, I would probably just leave it this way, and I'll explain on some other ones. There are situations where maybe I divide. What I want to make sure no student does is no student just tries to divide the 6 and the 2 without the 5 being divided. This could be rewritten, let me rewrite it one way, is negative 5x over 2 plus 6 over 2. Okay, you could write it that way. I want to make sure you're dividing everything by 2. And then if you wanted to, you could write it like this, negative 5 over 2x plus 3. You could write it one of these ways. This is going to be the way you're going to see it most down the road, but you could also do it this other way. All right, so let's try these ones as well. This doesn't say you try on it. We'll do these together. I want to make sure we practice. It's all solving for y, so we're going to try to isolate that. The first thing we're going to do is add x to both sides. 5y equals x plus 10. Notice I'm not putting my 10 and my x together somehow as if they're one thing. Sometimes students will all of a sudden write, well, it's 1x plus 10, so that's 11x. No. This is x plus 10. And then I'm going to divide by 5 on both sides. Y equals x plus 10 divided by 5. If I'm going to write this, and I want you guys to see this answer, if I divided both by 5, it would be x divided by 5 plus 2. 10 divided by 5 is 2. I'm going to write them this way. I want you to see it's okay if you leave them this way, but this is a very good answer. And again, later, this is going to be really important. This is how we're going to want things to be. Okay? We'll take a look at this next one here. All right, we're going to... I'm going to do something different, okay? Just for sake of this one, it looks a little different. So if I subtract 4x from both sides, negative 4y equals, and again, I want to make sure I want to make sure you're seeing that I'm writing it this way with the x in front to keep track of something later. And then I divide by negative 4, everything by negative 4. And I want to be really careful. Sorry, y equals negative 4 divided by negative 4 is 1, so just x, 1x, and then minus a positive 1 divided by negative 4 is negative 1/4. So you could leave it like this or like this. Again, this is going to be the answer that we're going to end up with down the road, so maybe get in the habit of it. All right? I'm going to pause the video. I want you to try this one on your own, and I'm going to ask you for the answer for this in your Ed Puzzle video. All right. So on this one, they've got this big thing here, and this they have this, and I want to kind of set this up. So S equals pi r squared plus pi r times L, and they want us to solve for L, to get L all by itself. Now, what I want to do is I want to show you that this problem is just like a simpler one. Let's say I gave you a problem that I think all of you can handle. Okay? Let's say I gave you a problem that said 6 equals, let's do 8. 8 equals 6 plus, sorry, I'm trying to make up a problem in my head, and when I do that, things get dangerous. Okay? We'll do 2 plus 3L. And we'll keep the L. I want you to see that if I asked you about this one, I don't think any of you would have as hard of a problem as you might on this one. So I want to try to keep track. You've got S, we'll leave black, is the same as 8. This guy right here is the same as 2. Right? All this, if we knew what R was, this would boil down to a number like 2. And then this 3 here is about the same as this pi R. Okay? It's what's being multiplied by L, and we'll leave L, as pink. Our final answer, L. So on this side, if I were to walk through this with you guys, I think you would all tell me the first thing you would do is subtract 2 from both sides. Okay? And that you would end up with a 6 equals 3 times L. And I want you to see over here, that's the same thing. First thing I can do is subtract this. It's being added to the thing that has the variable term, minus pi r squared. So these are going to cancel out, and you're going to be left with this on the side. Now, you can't actually subtract these. And this is where students get stuck, is they want to do more than they're being asked to do. I can't do s minus pi r squared. There's no math to actually subtract. So you just write it, and you leave it there in that kind of awkward state. Okay, and out. Then what I'm going to do on this side, we're going to go back and forth between these. Next, I think you guys would all say, oh yeah, you just divide by 3. These would cancel out, and you would end up with, 2 equals L. And so we're going to do the same thing over here. We're going to divide by pi r. Okay, and these are going to cancel out. And you have L equals, and all of this stuff, s minus pi r squared divided by pi r, you can't do anything with. You might be able to simplify a little bit, and I could rework it, but the idea is you found L. And I want you guys to see, up to this point, you guys have lived, I think even this for some of you we've been doing in this class, we're learning these things. And now all of a sudden they're saying, like, what if we take away all of the numbers? And what I want you guys to sit there and think is like, okay, wait a minute. If I know how to do this, this is actually exactly the same. And it's actually easier because I don't have to do 8 minus 2, not that that's hard, and I don't have to think of what 8 minus 2 is. And I don't have to do 6 divided by 3 and figure out what that is. I'm just like, s minus pi r squared is s minus pi r squared. And you just write it. Okay? It's a little ugly, it's a little weird, but you can break things down that way. Okay? So similarly, they're going to ask you for different things to do like this. And again, I want you guys to see, at the end of the day, all we're doing is adding, subtracting, multiplying, dividing. They're just letters. And we want to be comfortable in working with letters. Okay? So this one, we actually already did, so I'm going to skip that one. Here's simple interest. If you don't know what that is, simple interest is if you have a certain amount of money and it says you're going to get like 10% back for a certain amount of time, you kind of figure out how much interest you made. If I had $100 and every month I get 10% back, then after 1 month I got $10. Okay? After 2 months, now that's been 2 times, so now I have $20, so on and so forth. Simple interest. But they're saying solve for P. Well, let's see if we do this really quick. What kind of math is going on between here? It's multiplication. So to undo multiplication, you divide by R and T. We could divide by both at the same time. The R's will cancel out and the T's will cancel out. So P is equal to, if I do it to one side, I have to do it to the other, is equal to I'm going to put a capital I, divided by R, T. That's how you find out the principal. That's the original amount that you put in. If I knew how much interest I had, I could divide it by the rate of interest and the time, and I could figure out how much did I start with. Okay, this one's a little bigger. And again, I don't want it to seem overwhelming. Just try to go slow and consistent. This is just like the one we did a minute ago. We're going to start by subtracting 2 pi r squared. These will cancel out. So you got s minus 2 pi r squared equals 2 pi r h. And we want to find h, so then I'm going to divide by 2 pi r. This and this will cancel out. If I did it on one side, I could do it to the other, 2 pi r. And so h equals s minus 2 pi r squared divided by 2 pi r. And again, I would say this, I'm even stopping. You could simplify this a little more, but I'm fine with where this is at. You could leave it. If you're interested, this is only if you're interested. If you're not, close your eyes, plug your ears. Okay, you could simplify this to look like this. Sorry, minus r. Okay. The second part, the 2's cancel out, the pi's cancel out, and one of the r's cancel out. Okay. So you'd have something even a little simpler to help you out. All right. So all of this we're dealing with could help you in a practical situation if you knew conversion stuff, right? If there's a formula for converting from Fahrenheit to degrees, or degrees, Fahrenheit to Celsius, or Celsius to Fahrenheit, you could figure that out relatively simple. So it says solve the formula for F. Okay, so here's my formula. I want to make sure I kind of have it in my head. C equals 5 over 9 F minus 32. In case you didn't know this, just kind of a practical thing. You talk about this in science a little bit. 32 degrees is the freezing point of water. And so this formula kind of forms around that, where for us, if we talk about 32 degrees Fahrenheit, that's the freezing point of water. But in Celsius, that's 0. Okay? 0 is the freezing point of water. So they just are starting at different places. All right? So if I want to solve this formula for F, I'm going to start by multiplying by 9 over 5. Okay, 9 over 5. If I do it to one side, I have to do it to the other. So now I have this 9 over 5 times C equals F minus 32. And then I'm going to add 32 to both sides. So we have F equals 9 over 5C plus 32. Okay. And again, maybe this would come in handy if I ever did give you a temperature. I know, like, right, America is kind of like the country that does Fahrenheit. Everybody else in the world does things in Celsius. So if you ever went to another country and they're like, oh, the temperature is like 30 degrees, you're sitting there like, wow, okay, it's 30 degrees outside. That's really cold. But they're talking about Celsius, and maybe that's not as cold as you think. Okay, put 30 in here. Let's do this really quick, just for fun. All right? All of you are thinking like, this is not fun, Mr. Shanks. Don't do it. But let's say I had 30 degrees. Okay? These are going to cancel out, and you're going to get 6. All right? 9 times 6 is 54 plus 32. That's 86 degrees. All right? You heard 30, so you're like, parka, thermal underwear, beanie, your like snow boots, and then you walk outside and it's 86 degrees and you're like dripping sweat, right? Bad. So this is where this would come in handy for you, okay? So ultimately, they're giving us a situation, and we have this situation here. Which temperature is greater? The sun, which they're giving us is 11,000 degrees Fahrenheit, or a bolt of lightning, which is 30,000 degrees Celsius. So really on this situation, all you have to do is take one of them and convert it. So let's take lightning, because we just had that formula on the board. And we add 9/5 times Celsius plus 32 is going to give us Fahrenheit. So let's see, if we take this temperature, 30,000, okay, and kind of solve this, what are we going to get? Okay, well, we got to do some math here. So these are going to cancel out. It'll be 6,000. Okay. So 9 times 6,000 is 54,000 plus 32. So you get 54,032. Oops, sorry. Put too many zeros there. Okay. When you solve this. So here's the idea. This is how many degrees Fahrenheit the sun is. This is how many degrees Fahrenheit a bolt of lightning is. which means a bolt of lightning is hotter than the sun. I don't know that I would have thought that just off the top of my head, but clearly as we're seeing, like, we just did the math and converted them, and we get a difference there. So hopefully that's helpful, and you can kind of see where maybe this would come in handy. I don't know that you're doing like the temperature of the sun and like lightning all the time, but if you're ever traveling, it's something to be aware of. There's other formulas like this that are really handy to know and really helpful for us in solving. Okay, so there's one other one on here. I'm going to leave that for you guys to answer in your Edpuzzle video, and look forward to answering any questions you have and helping you on the back end with any needs that you have.